All right, hello everybody, and welcome to this one-hour webinar on iOS development using Swift, presented by WebAge Solutions. So, just off the top here to answer a couple questions that are typically asked by folks, we will have time at the end of this webinar for some open Q&A. So, in your interface there, in the GoToWebinar, there is a section labeled Questions, and you can type questions into that section. And feel free to do that as we're going along here. However, what I will do is answer those questions when we get to the end. So, as we're going, feel free to type one in there, and then when we get to the end, I'll scroll through them, and we'll get through as many as we can. I don't think we're going to have a really large group today, so that'll be good. We should be able to get through all the questions. Another thing that comes up is the slides for this presentation will be available to you after the presentation, and also a recording will also be available via the WebAge website as well, and you'll get information about that. Okay. All right, so a little bit about me. My name is Jason Bell, and I first started doing software on one of these guys, TI-99, back in 1982 or so, and been sort of along the ride ever since. I've been recently spending my time typically in one of these four areas. You can see here C-based languages, Swift, and then I'm looking at some of the Xamarin stuff now too for doing cross-platform development. And we will actually talk a little bit about that as far as the decision-making process of if you're going to develop for mobile applications, do you want to look at a native solution like what we're primarily going to be focusing on, or is a cross-platform solution maybe something that's more appropriate for the kind of application that you're going to build? So we will talk some about that. I've been doing development for Apple stuff since the release of OS X, and actually before that on 2E and what have you, and then with the introduction of the iOS with the iPhone. So, yeah. All right. So one thing I want to bring up right off the bat here is we do actually offer a 5-day full training course on iOS development with Swift because it is a large topic and there's a lot to talk about and a lot to cover. So here's the outline for the 5-day version. And this is where we get into all sorts of different things. Basically, full coverage of the Swift language, iOS architecture, things like auto layout to make your UIs more adaptive, more stuff with the Swift language, protocols, table views, error handling, networking, local storage, multi-taps and gestures, drawing, animation, notifications, core location, localization for different languages and cultures and things, performance, and so on and so on. So lots of stuff in there. So the idea here, we obviously just have 1 hour. Versus a full 5 days. And so what we're really going to focus on is sort of what would lead you down the road of choosing to do native development with Swift, and then some of the things that sort of make Swift special. Why is Swift different than other languages? To make you more productive or to produce code that produces less errors, crashes, things like that, and really what makes it sort of special. All right. So, all right. Okay, I put a short URL here in the slides, and I will also, I think I will put the URL in the chat window as well, because sometimes that makes it a little easier for folks to click on it and things like that. So there you go, link in the chat window. And so we do actually have an upcoming session of this coming up at the end of this month. And you actually do get a discount if you're a webinar attendee. All right, so I may talk a little bit more about that at the end and if people have questions and things. Okay, so our agenda today, we want to talk about sort of the mobile landscape and development options. So some of that, like I talked about, of why you might choose Swift and native development versus some cross-platform options. We'll look at a little bit of the basics of iOS development as far as how things are put together and how you'd approach building a iOS application using Swift. And then again, some of those things that make Swift a little different. And then near the end, I'll briefly mention Swift 4 and Xcode 9 and just some of the exciting things that are happening. We just had Apple Worldwide Developer Conference last week. And when that comes around every year, we get to hear all the new and exciting things that are happening with Swift, Xcode, and the other things in the Apple ecosystem. Okay, so as I'm sort of getting into this first part here about the mobile landscape and options, I actually have a couple of quick polls for you guys just to see sort of where everybody's at. So I'm going to go ahead and start the first one here, which is just what is your level of experience with iOS development? And you can sort of just, click on that if you'd like. We can see where everybody's sort of at. So mobile landscape. So the first part of our decision process here is you decide, I want to build an application for mobile platforms. All right, well, the way things are right now, sort of worldwide, we've got Android, we've got iOS. Between the two of them, we're looking at probably 95% and up user base. It's bouncing right around 80–85%, and iOS has been right around 15–20%. There aren't a lot of users available in the iOS camp, for example. You have millions and millions of users around the world that are using iOS. But if we go after those, we can cover quite a bit. Okay. The other players like Windows Phone and things have sort of, made their way out, so to speak. We're talking less than 1% for those two combined. So it's kind of where we sit. So the next option is going to be, and let me stop the poll here real quick. And so let's see where we're at. Let's take a look. All right, so of the folks we have on here right now, about 65% say they don't have any experience with iOS development. We've got about 27% with some Objective-C and about 10% with some Swift. So that's good. That's sort of what we kind of plan for. So while I continue here, let me go ahead and put up the next one, which is what are your future plans? Right. Okay, so the next choice we get into when we decide we're going to develop for mobile is, are we going to do native development or are we going to do some sort of cross-platform option? And we're going to talk about sort of the advantages and disadvantages briefly, and then jump into iOS and Swift. So let's say we're going to go after iOS and Android. Android, native develop on Android, you're going to be using, up to this point, it had been Java. Now Google's got a new language called Kotlin, which is actually really familiar or really similar to Swift. They're both modern languages that have been created somewhat recently, and there's even some blog bring Swift to Kotlin, and really
Sorry, Jason, for some reason, we stopped listening to you.
Have an audio issue?
Yeah, I think you have a little audio issue. It's gone a couple of times, 2–3 times.
Oh, all right.
For the last minute or two.
Okay. So with Swift and Kotlin, if you decide you're going to build it twice, they're actually really similar. So yes, you're going to have to write the code twice. But if you write your iOS code in Swift, but they'll actually be very similar now. So that's really good. All right, the poll that we had going was, what are your plans for Swift? All right, so about half of folks are currently comparing it to other options, which is a good thing to do. And again, we'll talk some more about that. We do have about 10% that are most likely using it, and then 40% not sure. Hopefully we'll put some more people in that definitely will be using it at the end of today, yeah? All right. Cool. And the development tool on the Android side is Android Studio. Now, on the iOS side, if we're doing native development, we'll be looking at either Swift or Objective-C together and compare Xcode, which is provided by Apple. However, we are seeing other options sort of come about. There's another IDE. It's a very similar workflow to what you get from Xcode. It just feels a little different. Everybody has their own opinions on what they like with their development environment, but that's sort of where we would be. Now, the cross-platform development options, there are quite a few of them out there. So if we're going to want to cover the users on Android and iOS, say, we could build it as a pure web application. Runs in a browser. In that case, we're going to cover everybody that can run a web browser on their device, which will pretty much be everybody. The other option is sort of a hybrid, but HTML-based. So in other words, they install an app on their phone. It looks like an app. There's an icon on the home screen. They click on it. It launches like an app. but the content that you're actually displaying within the app will be HTML-based. The advantages to that sort of approach is you can use your existing web development knowledge if you have that. The disadvantage is you lose a lot of the abilities that you get from building native for the platform. So things like accessibility, localization, things that you'd normally get for free in a native application. If you're in a web-based application, it's a different world. It's a web app, right? So you're not going to get that. You're also going to have to be much more limited as far as being able to access the native hardware or native features available on the platform. So accessing things like the compass or the accelerometer or GPS, things like that. But depending on the type of your application, right? If you're building an application which is simply a data presentation app that talks to a web service and presents data, a web application or a hybrid application may be perfectly fine. Now, some people actually will build their iOS application using the native stuff that we're going to look at here in a moment, and then put a sort of web browser control within their app. What you're doing at that point is you're really building this hybrid kind of application. Apple sort of discourages that. They say that you can include web content in your app, that's fine, for things like documentation, help, what have you, but you shouldn't be using it to construct your user interface. Because again, it's not going to change when new versions of the platform come out. So when iOS 11 comes out, if certain things are changed as far as how buttons look, your web application or your web-based application won't reflect that. And for accessibility features and other things. We have native cross-platform frameworks available now, and they've been evolving over the past several years. We have Xamarin that's been acquired by Microsoft, React Native, AppCelerator, Qt. These all will use different languages and different techniques, but what they'll do is when you say that you want to display a button on the screen, they will actually render a native platform button. So you will actually end up with a native UI, which ends up on the screen, and so that way you'll get the features of the platform, you can get access to things. Those weren't that great several years back. They're starting to evolve now and get a little better. But what's important to us is to think about, okay, what are the advantages of maybe choosing cross-platform versus the advantages of building native? So obviously, for cross-platform, the goal here is write once, run everywhere. So the ability to reuse code across multiple platforms, and then also to leverage your existing language knowledge or framework knowledge. So if you already know C#, you've been doing it for 10 years, and you really like it, well, you're probably highly motivated to want to use C# to build something that can run on all platforms. And so you'd look at a solution like Xamarin, for example. Where if we're going to build twice, sure, Kotlin and Swift may be really, really similar, but we still have to write it twice. Right? And that's typically what it comes down to. Whether a cross-platform solution will work for you sort of depends on the application you're building, and you have to look at it. And some organizations, like Facebook, for example, have learned the hard way, where they've tried to write an application for multiple platforms one time, and at the end of the day, they ended up writing it 3 times because it wasn't just producing the user experience and the quality they wanted to meet the requirements, and so then they ended up having to build it native at the end of the day. So the downsides of the cross-platform options, like we said, you may still have to build your GUI multiple times. So there's a lot of code that you might be able to share across platforms very easily. So your networking code, your file access code, your business objects, your logic, validation rules, things like that. But when it comes to building the user interface, depending on your app, you may actually have to build that multiple times, for each platform. Now, things like Xamarin and other cross-platform tools allow you to do that sort of thing, where you can build the GUI multiple times and put them on top of something that will run everywhere. And again, it depends on your app. If your app really has a very, very simplistic user interface, but you've got a lot of code which is not UI related, that type of approach may work well. On the other hand, if your application does a lot with the user interface, has a very compelling interactive UI, and that's where most of your code and most of your work is at, then building that twice, you might as well build the whole thing twice. Right? The other thing with cross-platform options is you may not have access to all of the native functionality, all of the underlying hardware that's available on the platform. If you want that, building native is always the way to go. New native features may not be available right away. when Apple has WWDC and they say, hey, look at all this new stuff we've done on the iPad. You've got drag and drop and multitasking and all. Well, if you're building it native using Swift and Xcode and all the Apple's tools, you know you have those features available now because it's their stuff, it's their platform. All right, where if you're using something else that's cross-platform, you may have to wait for them to update their things, and even when they provide those access to those features, they may not provide everything. They may just provide what they think is the most common use case, and so forth. And then performance and offline functionality. Building native using Objective-C or Swift, like we'll talk about, will always give you the best performance and the most options when it comes to running offline, handling the life cycle of the application. So when it goes from active to suspended to terminated and then back to active again, and the life cycle is a little different on different platforms. And so if you really want to provide a good user experience when it comes to life cycle management, native is the way to go there too. Now, with iOS, we got a couple options here. We're going to dive into code, and we're going to be doing demos very, very soon, and we'll be done with these slides. But we do have two options when we choose a language for iOS native development, Objective-C and Swift. And some people in the poll said they had some experience with Objective-C. So Objective-C has been around for a really long time. The language itself has actually been around since around the same time as C++. And C++ and Objective-C had really the same goals, which is to add object-oriented extensions or things on top of C. And so when Apple acquired Next, and it became the basis for the OS X operating system, and then iOS was sort of based on OS X, we got Objective-C sort of along with the package. Okay, but the point is, it's still there, it's still available, it's still fully supported. You can use it. It's not going anywhere anytime soon. However, a few years ago, Apple introduced the world to Swift, a brand new language created from scratch. Chris Lattner was the individual that was the primary developer of Swift in the beginning, and he took ideas from other modern languages like Java and C# and Ruby and all sorts of others to create something that was really had features that people expect now from their programming language and sort of a replacement for Objective-C. It was originally described as sort of Objective-C without the C stuff. Right? It's been open source now as of 2015, and so Swift.org, we're to jump over here to just Swift.org. This is the home of all things Swift when it comes to the language itself. So if you're interested in sort of what's going on with, and I'll bring it up here in just 1 second. If you're interested in what's going on with the language, this is a great place to go. You can even contribute to the project, but there's good documentation here on the Swift language. There's a big old EPUB you can download on the Swift programming language. But this is also, you can see they have already got an item here for migrating to Swift 4. But you can see what they're looking at, what they're considering for new features in future versions of the language and things like that. All right. Apple contributes to this. You can see it uses an Apple certificate, but this is the home of the language itself. Okay. And so it is the recommended choice for new app development. However, they can interoperate with each other really well. So if you have an existing application that's built using Objective-C and you want to add some new features to that Objective-C app, you can actually do it using Swift. So your Objective-C can call your Swift code can call your Objective-C code. This is one of those topics we look at in our 5-day course as far as how interoperability works and sort of the best practices around that. But they can work together really well. But Apple now recommends if you're building anything new, you go ahead and use Swift, okay? Because you'll get a lot of those modern features that you really sort of expect nowadays, and you'll be in a better place, okay? All right, the future of Swift. A lot of organizations and things have expressed a lot of interest in Swift, and a lot of folks really like it. And so organizations like IBM, Google, and some big app providers like Facebook and Uber have made statements that Swift is really interesting to them, and they're going to continue to work on things to sort of promote Swift and extend Swift. So, for example, if you go to IBM's site, developer.ibm.com/Swift, they'll have stuff in there about doing server-side development using Swift. So you can build your web services with Swift as well as your iOS application with Swift. Same language everywhere. And I mentioned here in the slide that there are some other server-side web frameworks that are coming out. Perfect, Vapor, Katura, those are just a few. And so we're starting to see it sort of appear in more places, which is great. How far will it go? How many people will use it? Yeah, we'll see, right? But pretty cool. And just sort of one note here, Stack Overflow likes to do a survey of sort of what languages do you like, what languages do you not like, and so I've got up here on the screen the list of the most loved programming language, and you see Swift has made its way up here to number 4. I think it was number 2 last year, actually. So it's pretty high up on the list. Notice Objective-C is not anywhere in this list. Java's way down here. If we go over to sort of most dreaded, yeah, VB6, VBA, okay, there's C++. There's Objective-C, pretty high up. Okay, so people do really like it. Okay, and once you sort of get your hands on it and really sort of start to understand kind of why Swift does certain things the way that it does, and you have an idea of kind of what they were thinking when they did that, most folks sort of think, yes, I do like, you know, kind of what they were thinking when they did this, and programmers tend to be happier when they're writing less errors and their stuff runs faster, right? So Swift will help you do that. Okay, Swift has been evolving. Version 1, 2, 3, 4. 4 was announced just last week that it's coming. If you're on Swift.org, you'd seen it before that, but you can kind of see a pattern here, right? About September of every year, we get a new major release of Swift. The transition from Swift 2 to Swift 3 was somewhat significant. There was a lot of breaking changes there, a lot of new stuff. From Swift 3 to Swift 4, it's more of a minor evolution. We see some improvements to things like the string type and accessibility modifiers, things like that, but nothing that's going to require a significant amount of rewrite. So if you start building an application today, you're using Xcode 8 with Swift 3, and then in a few months, you start using Xcode 9 and Swift 4, the changes you'll have to make will be very minor, all right, which is a good thing. Okay. So development tools. We're going to do native iOS development with Swift, so we're probably going to be using Xcode from Apple. We've got some simulators included to be able to run our applications on devices. We can either run them on physical devices, which I'll just talk about briefly, or on software-based simulators that come with Xcode. We also have instruments for doing performance analysis and testing and things. So if I jump over here, I saw in the survey that a lot of people said they didn't have any experience with doing iOS development. So I'm going to open up Xcode here and just sort of do a really quick sort of look at what's going on. So we'll say we want to create a new project, and again, we have the ability to choose sort of what kind of starting point we'd like for our application. So if we'd like a template that has a nice master detail application already built for us, and then we could just modify that, or we could just go something like a single view application. iOS runs in a variety of different places, so we can target phones, iPhones, iPads, watchOS, tvOS. We can build desktop apps with Swift, all right, for macOS, okay? All right, so we'll go iOS, we'll go single view application. We'll give this thing a name. And here's where we actually get to choose our language. So yes, you still get the choice, Swift or Objective-C, or like we said earlier, you can mix them. So I can create an Objective-C app and add Swift to it later. I can create a Swift app and add Objective-C to it later if I really want to, okay? All right. Other frameworks we can use, we can do unit testing. There's good support in Xcode and in Swift for being able to write unit tests and be able to run your unit tests from the tool, even stuff with your UI. Again, this is another topic that we cover in the full 5-day. So I won't check those now, but I'll go ahead and create this. Good integration with Git for source control, things like that. I'm just going to create a folder on my desktop here. All right, and so off we go. Okay, we've got some files in here for writing our Swift source code that all end with .swift. We have storyboard files for being able to build our user interface in a nice visual sort of way. So this is kind of what you'd expect, the ability to drag and drop controls, and then eventually be able to write event handlers and things, which I'll talk about in a little bit. Very similar to what you'd expect in other environments. So if you've been developing iOS applications with Objective-C, how you design your UI, how you connect your UI elements to your code is all the same. It's just we're using a different language now to write that code. If I was using Android Studio and using Kotlin or Java, it'd pretty much be the same process. It's just the UI is going to look a little different, the tool is going to be a little different, but in both cases, behind the scenes, these storyboard files are actually just XML. All right? Now with the Apple tools and things, they don't really expect you to be editing this manually as text. We'll do things visually and let it generate it for us. On the Android side, it's the same process, but you have a little more capability to edit the text manually. But in both cases, you have that ability to do that. All right. So instruments I mentioned. One thing I will sort of recommend that if you start getting into iOS development with Swift, you definitely spend some time taking a look at the Instruments tool. This tool gives you the ability to sort of examine your application while it's running, so you can see how much memory you're using, how much of the battery you're using, when you're accessing the disk, when you're accessing the GPS, all those sorts of things. So you can really profile your application and see if you're being nice to your users, because we've got to remember our users only have a limited amount of battery, and they may be paying for the amount of data they use. And so we can monitor our application to make sure we're using the minimal amount of data, we're not killing their battery, things like that. All right, so Instruments is one of those tools that it's there, but a lot of people just don't pay it enough attention. So yes, definitely learn Swift, definitely learn Xcode, but don't ignore Instruments. It's a great tool, and you can really use that to improve your applications. Okay. All right, so when we talk about learning iOS development or Android or any type of development, there's typically three things we need to learn, three areas, right? The language we're going to be writing our code with, and so we're going to talk about some features of Swift here in a minute. The tool we're using to write our code, which Xcode there that I just was showing, and the frameworks and libraries that we can use to build our application. So in other words, the code that's there but that we're not writing. So Apple makes this available via the iOS SDK, and so this is where all the different components are for doing network access, reading from the disk, deserializing JSON, drawing on the screen, whatever it happens to be. Okay. And so you can also get third-party libraries and things like you'd expect for your applications. So I can go down here and I can add additional sort of frameworks, either from the SDK that's available, so things like Chord Location and AudioKit and CloudKit, Contacts, all these different things, or also third-party ones that other folks have written that you can basically add to your application. One of those things, do you want to write it yourself? Do you want to use somebody else's? All right. It's in layers. We don't need to talk too much about this, I think, but the point I want to make here is there are some lower level components that are available to you on iOS that are written as C libraries. So as we go down the stack, when we're up high on the stack, we're doing UI type things. Things are very object oriented. They're typically very easy to use. As we start moving down the stack, we get to the point where we're using libraries and code that's just written in straight C, which we can still use from Swift. We can still interact with that from Swift. It makes your Swift code not as beautiful and clean as it usually is, but you can interact with those lower layers. And so I just wanted to sort of make that point. If you want to use something like SQLite or another library that's out there that's written in C, you can use it in your Swift application. There is interoperability there between Swift and C code. Okay, and so the other point I want to make here is when you're trying to accomplish a task in iOS and Swift, you should see if there's a high-level component that can do it for you, something in the Cocoa Touch layers, things like that, that feel very Swifty, right? And if not, you can drop down as low as you need to get what you need to do. So like drawing on the screen, for example, we can draw very low level, very manually, or we can use some of the high-level stuff for doing more simple drawing, right? And so you'll be bouncing up and down this sort of stack as you go, okay? And lots of frameworks that are out there. Apple does a pretty good job of grouping these, and so depending on what you need to do, a lot of these end with kit, right? So I need to do stuff with push notifications, so I'll use stuff in the PushKit framework, or I'm going to use mapping in my application, so I've got MapKit or WatchKit for doing things that are specific to the Apple Watch. And so again, in our 5-day course, we can't cover all this stuff, but we do cover quite a few of these different things and build some applications. And I'll actually show you an application that we end up building at the end of that course as well. Okay, so getting started. You want to develop native iOS applications using Swift. You thought about the multi-platform stuff, but you said, nope, I really want to go native. I want to use Swift. You can do everything free. So you install Xcode on your Mac, which Xcode is free. You have an Apple ID, which is free, and everybody that's got a Mac or has a phone probably has an Apple ID. And so what you can do in Xcode is just add your Apple ID to the accounts section here in Xcode. And what this will allow you to do is write applications using Swift and run them in the simulator and be able to run them on your physical device. And so you can plug your phone into your Mac and be able to launch your app on your physical phone and be able to use it. And then you can even unplug your phone from your Mac and go off and use your app out in the wild. All that can be done for free. That's fine. It was announced last week that they're going to start supporting wireless development as well, so you don't even need to plug your phone into your computer to run your app on it. You can do it wirelessly, which is really nice. Now, if you get to the point where you want to put your app on the App Store and either provide it for free or charge money for it, or you want to use some of the test flight stuff to allow for beta testers to be able to use your app and get app analytics and things like that, then you need a membership. So $99 for an individual or an organization, and this will allow you to publish things to the App Store and distribute your app to other folks. Okay. There's also another membership that's available called the Enterprise Program. So if you'd like to, in effect, run your own App Store, so you want to develop apps for your organization, but you want to distribute them only within your organization, it's a different program, but the process will still pretty much be the same. If you're putting stuff on the Apple App Store, there is an approval process where Apple will actually review your app before they let it onto the App Store. This is to make sure people aren't doing things that are malicious, or that the app doesn't crash all the time, or you're not using up the user's battery unnecessarily, that Apple just checks for those sorts of things. If you do in-house distribution, Apple doesn't look at your app. It's just all your own deal. All right? Okay, so Swift language. Let's get in here and write some Swift. So some of the features or the goals of Swift, like we said, is to be modern. So we have things like inferred typing. So you can say, var I equals something, and you don't have to specify a data type. It can figure it out based on what value you're giving to it. Closures, or if you've used other languages before, if you've done lambda expressions or anonymous functions, similar sort of thing, right? Tuples, generics, it's safe. So variables are always initialized before use, and we're going to talk more about this. We do have automatic memory management. We've had that in Objective-C for a while, but memory is managed for us automatically using automatic reference counting. And fast. One of the points of Swift was that we don't want it to be an interpreted language or a just-in-time compiled language. When you write code in Swift and you build it, you get ARM assembly and eventually the machine code that runs on the device. And so Swift will be as fast, or in some cases faster, than what you'd write in Objective-C, for example. Okay, so it can be used as sort of a systems programming language when you write your Swift code. Okay, not interpreted, not just-in-time compiled. Now we'll talk about some of the steps that the compiler goes through, just to give you guys a little peek behind the curtain. But that was a goal of Swift, is to be a very fast, systems-capable programming language, and not something that's like a scripting language. Okay, interactive. Swift is cool because we can use it at the command line or in playgrounds, which I'll talk about what that is, in a very interactive way. It makes it really great for learning. You can type code, it can execute immediately, you can see what's happening. It really makes it easier to learn and experiment with the language. Interoperable. We sort of already mentioned it, but there's a lot of great interoperability to make it so that your Swift can talk to Objective-C or C and vice versa. Okay. Sometimes I get folks that ask about C++, and can Swift call C++, or can C++ call Swift? Not directly. If you want to talk to some C++ stuff from Swift, you'll usually provide a wrapper or functions in C that then call the C++ or things like that. Okay, so you can do some things, but not sort of directly. Okay, let me just do one thing here. Okay, stop those notifications coming up. So Swift environments. If we want to start writing some Swift and jump off the ground here, we can do it from the command line. We can use an IDE like Xcode, or we could use a different IDE like the JetBrains, like I mentioned before. So let's do a little of that. All right, so I'm going to jump over here, and if you've got a Mac and you've got Xcode installed, you can sort of go along with me if you'd like. And again, there's lots of tutorials and things out on the web for getting Hello World to work and stuff in Xcode. So I'm going to do a little bit of that, but I actually want to show you guys some stuff you usually don't see, which is a little bit of the behind the scenes with Swift and things. So what I have here is I have a text file, and I just put one line of Swift code in here. It's called hello.swift. And notice a couple things. One, this is a valid Swift program, but I don't have like a main method or anything. I don't have an entry point. When we're talking about Swift, any code that's at the top level, so in other words, code that's not in a class or not in a function, will just get executed from the top down. Okay, and so this is a perfectly valid Swift program as it sits. I don't have a semicolon here. You can put semicolons in your Swift if you want. That's fine. However, other Swift programmers, will look at your code and say, yeah, this is somebody that's coming from another language where they're used to doing that. In Swift, we usually don't put on the semicolons unless we have to. When would we have to? Well, you want to put multiple things on one line or something. You need the semicolon to separate them. But it's not actually we do more like something like this. Okay. But yeah, we don't usually use semicolons. Okay, but I've got this text file, so what I'm going to do is I'm going to jump over to the command line here, and I'm going to use the Swift compiler, which is just Swift C. And if I just type that, it says, hey, no input files. But that does tell me that I have the compiler. I'm just not giving it anything to compile. So we'll say Swift C, and you're going to use our hello.swift. All right, and so what just appeared on my desktop is an executable. This is actually a Mac OS desktop executable. So that means I should be able to run this. Yep. All right. Now, if I look at the Swift compiler, there are lots of other things I can do with it. Okay. Now, this is the same compiler that Xcode uses. When you click Build in Xcode or you click Run in Xcode, it's going to use the Swift compiler to compile our Swift code into what it needs to. Now, there's a couple of intermediate steps that it goes through. Now, do you need to know this to be a Swift developer in iOS? No, you don't really need to know this, but some people like to sort of see what's going on behind the scenes a little bit. So first thing that's going to happen is I'm going to say Swift C, and I'm going to use my hello.swift here again. But this time, instead of just compiling it and building my executable, what I'm going to do is I'm going to actually ask to, let's say, dump the AST. And that's the abstract syntax tree. So the compiler is going through and basically taking our code and transforming it into a different form before it goes to then compile this down to something else. So let's look at something else. How about we say emit SIL. So this is Swift Intermediate Language. Now, if you've used another sort of environment like, say, .NET, you write C# in .NET, and you hit build, and it compiles it to this intermediate language. And the intermediate language is what you give to your users. It's what they're going to run. So when they double-click on your app, it then just-in-time compiles that IL code into machine code to run on the machine. Yes, that sort of thing is happening here, but it's happening at compile time. In other words, we are not putting this on our users' phones, and then it's getting compiled again on their phones, right? This is just an intermediate step the compiler uses to generate our application. So after it goes to this IL, then it's going to end up going to something else, which is LLVMIR. It's an intermediate representation used by the LLVM compiler. And then eventually I could really go down and say, well, I want to see the assembly. And so the reason I'm showing you this, again, do you need to know this? No. But if you want to prove to yourself, if you're a long-time Objective-C developer or a Java developer or whatever, and you say, hey, I'm going to write a little application, and I actually want to dig down deep here and actually prove to myself that it's using efficient assembly instructions to add two numbers together or whatever it happens to be, right? To actually, see the output that's coming in before you get your executable, okay? And so that can be kind of fun to just experiment with that and play around and stuff. And so you can look at the compiler. Cool. All right, so A little bit of fun at the command line there. I said that now another place that you can write Swift code. Oh, let me show you this, by the way. If I just type Swift, what this does is it actually launches an interactive prompt here where I can type Swift code right at the command line. So I could say something like, var I equals 5. Now I've got a variable which has a value of 5, and then maybe I'll add something to it, and then I'll ask for the value of I, and it's 7. And so nice little read, evaluate, print loop here where I can type Swift, have it execute right away, and sort of play around with it. Most folks aren't going to do that, though. What they'll do if they're learning Swift is they'll use a playground. Playground is something we can create with Xcode, and it gives us that same ability to sort of experiment and learn about Swift interactively without having to create a full-blown iOS application and then learn all that other stuff that goes with doing that. Okay, so take a look at that real quick. So come over here to Xcode, and instead of File New Project, like I did for this app here, I'm going to say File New Playground, and we'll just give it a name, and we'll put this somewhere, maybe on my desktop or something. It doesn't really matter. Don't need any of this. And this is where I can just start typing some Swift. Okay, so maybe I'll create a variable again here called A. We'll set it to 5, and you can see I can actually look over here and get that interactive experience again. And playgrounds are really interesting because you don't sure, you can type code that just adds numbers and prints strings, but you could also do graphics and animations and drawings just right here in this nice playground. And then once you sort of figure out how something works, you could take this code, copy and paste it into your Xcode project or what have you. So playgrounds are really great. I encourage you, if you go to developer.apple.com, you can sort of look at lots of examples that use playgrounds and things just for doing experiments with the language and learning how stuff works. Okay. All right, so let's talk about some features that are specific to the language. I said that we just cover a few here that really makes Swift kind of different and special. Okay, because when it really comes down to it, when we talk about a new programming like Swift, if they're doing a good job when they create the language, it means that when I write my code, I should be writing less errors. It should take me less time to write my app. And at the end, it should be a higher quality application. It should crash less. It should perform better, right? So one of the things Swift does is it highly encourages the use of constants whenever possible, okay? So when I'm over here, I'm in my playground right now. When I did this, I created a variable. I used implicit typing. When I say implicit typing, it means that this A that I just created is an integer, okay? Because that's the value that I gave to it. If I try to change this to something else later, it's not going to like that. I get an error here and it says cannot assign value of type string to int. So if you've done stuff with JavaScript and things like that, the var here is different, right? It's implicit typing. It figures out what it is, and that's the type it is forever. It can't change to some other type later. Okay, so it is strongly typed. It's a good thing. Okay. Now, because it's a variable, though, I can change its value. I can't change its type, but I can change its value. However, in Swift, best practice is we'll always make things constants whenever that's possible. So a lot of times when you look at your code, you end up creating storage locations and you put something in there, but then they don't end up changing later. You don't have to modify them. Even if I'm reading data from a web service, I create some storage locations, I grab data from the web service, I put them into these storage locations, and then I display them on the screen or use them, but I don't modify them, okay? And if they're typing in text boxes and things on the screen, maybe we're creating a new whatever it is, person or employee or something. So anyway, in Swift, we always want to use constants via the let keyword whenever we can. And then when we realize later that, well, no, this actually does need to be something that's modifiable, tool will tell me. It says, hey, change this let to a var to make it mutable, okay? If you make something a var but you never change it, the compiler won't tell you. If you make something a constant and then you try to change it, it will tell you. And so that's a good thing. Kind of like we always make things private, as much as we can, and we only make them public when we really have to. Makes it easier to maintain them. You know? So I could click the little suggestion here that says, fix it, change the let to a var to make it mutable. Oh, okay. Yeah, and it'll do that for me. The same thing as when you're writing your project in Xcode. One thing I just want to mention about these little fix-its that come up is that sometimes the fix-it is not necessarily what you want to do. Okay, you should ask yourself, okay, well, is it that I want to change this to a var, or is this something I really shouldn't be using in this way? It should be a new variable, or it should be something different. So you shouldn't just always just click the fix-it, right, without understanding what's going on. Okay, but constants and variables, the great thing about constants is it's a better expression of intent that you're saying this is something I don't intend to be modified later. The compiler can do all sorts of really good optimizations because it knows it's not going to change. And side effects. If we're doing multi-threaded things, we got code running in multiple threads, it's fine for multiple threads to read data from a place if that data doesn't change. Shared state is okay if the state doesn't change. Okay, and so constants will help us there. All right? And that was kind of what I was just doing there. Now, probably the number one thing that people have trouble with when they come to Swift is this idea of optionals. Okay, and this is also the number one cause of bugs and issues in other languages. Okay, so for example, here I have a little bit of C#. Okay, this is Visual Studio for Mac. It's .NET Core. And what I'm trying to do is I'm trying to use an object that hasn't been initialized, hasn't been set. Okay, if we look at another language like C#, we have this idea of value types and reference types. Reference types are like pointers in Objective-C, right? You point to something that's in dynamic memory. And so a person here is a reference type. And so it can be nil or null, right? And if I try to use an object which is null or hasn't been initialized, things are not going to go well for me, right? I get a runtime error, very common runtime error, which is I'm trying to access or use an object that's null. And so what I get is I get this, null reference exception. Object reference sent to it, not set to an instance of an object. Very common sort of error, okay? But it's a bad one because it's a runtime error, not sort of a compiler time error. The compiler doesn't pick up on this. If I have something that's a value type, like an integer, that thing by default cannot be nil or null, okay? It defaults to 0, okay? But they're different, right? Got value types, they can't be null, but I got reference types, they can be null. If I access a null thing, it's going to blow it up. All right, well, in Objective-C, the situation was similar, but in some respects, even a little bit worse. So here I have a iPhone Objective-C application. And so let me run this. So I'm in Xcode. I run the application. It launches the iOS simulator. And this application talks to a web service and retrieves some sample data from a web service, displays it in a list, and then I can sort of navigate around in my app and look at these different things. So up comes the app, and this is the stuff coming from the web service, so I can click on something and see the details and what have you. This is a type of application that we actually build during the one-week course. So we write all the code to talk to the web service, to work with the JSON data, to handle any errors that occur, this sort of thing. But what I want to show you, why I was bringing this up, is in my Objective-C code here, I have this repository object. Okay, it's of type NW repository. And I allocate it and I initialize it, and then I start calling methods on it, like fetch all categories. Well, what would happen if this thing was just nil, right? It was never created, it was never initialized. The variable's there, the pointer's there, but it doesn't point to anything. I don't get a compiler error or warning or what have you. Then when I run it, we'll see what happens. Okay? And it doesn't blow the application up. It runs, it launches. Yep, there's my list. And anybody who's done Objective-C development have probably run into this before, where you're sending messages to nil, basically, and that's permitted. It allows some really interesting, flexible things you can do in Objective-C, but it can also make some bugs and issues harder to track down. So in the past, before we had automatic memory management, reference counting, the most common error was people either releasing memory too much or trying to access something after it was released. once that got taken care of, now the most common error in Objective-C applications is, using things that are uninitialized or using things that are nil. So where am I going with all this? Well, in Swift, everything, whether it be a value type or a reference type or a constant or a variable, everything must have a value at all times. In other words, it cannot be nil or it cannot be null. Now, if you think about that for a second, that can make the programming language much more safe, all right, and much less prone to errors, because every time I ever have anything, I know that thing will never be nil or never be null. It'll always have a legitimate initialized value, always. Now, of course, in your code, though, there are some times where you need something to represent absence of value, right? It doesn't have a value. So then we can use an optional, okay? So let me just talk about this for a second, and let me bring up my playground. And so if I declare a variable, like my a here, I cannot at some point later set that to, absence of value. All right, let's try nil, for example. All right, and we'll see what it says. Whoop. All right, I killed that, but that's okay. But it's not going to let me do this, okay? Now, if I do want something to be able to represent absence of value, right, I can give this thing a type, and I can say, all right, this thing is going to be an optional int, okay? And so, yes, I can set it to something, another integer. That's fine, right? Or I can make it nil, right? Now, normally you don't see that ever written that way. What people will do is they'll say, well, we'll use a question mark, right? This thing's an optional, right? And so that I can set it to nil. The point I'm trying to get across here is things that cannot be nil, cannot be null, is a good thing. It puts me in a happy place because it makes my code safe. It's great. If I need something to be able to represent nil, I will do that, okay? But now, when I go to use this, so let's say I want to say let A equal, or let B equal A plus 1, okay? So this is unhappy. It says error, value of optional type int not unwrapped. Did you mean to use exclamation point or question mark? So in other words, what I have here now, because I'm using an optional int, it's not an int. It's a wrapper around an int because it can represent nil or nothing, okay? So I have to do something about that. So I can unwrap it, right? Force unwrap it and basically say, take this wrapper that I have here and then unwrap that thing, and I get a 6, which is what I expect, okay? But that's unsafe, right? So Swift forces you to be a little more explicit about what's going on. You say, well, no, I need this thing to be able to be nil, but now I know that's going to introduce problems. So when I go to use this thing, I'm going to have to unwrap it, but I know that's inherently unsafe. So when I'm writing my Swift code, I should maybe do something about that. I should say something like, well, if A is not equal to nil, and I actually don't need the parentheses here, then we'll do something with it. Then we'll unwrap it. So then we'll say, let C equal, A plus 2. But now I know that's safe because I'm checking, okay? Now, in the full 5-day course, we probably spend almost half a day talking about all the things that you can do with optionals and sort of to make your life a little easier. So just as a quick example here, what I could do is I could write something like this. I could say if x, let's say if let x equal a, and then inside here we'll do something with it. We'll say let C equal x plus 2. So it's sort of a conditional unwrapping, right? Just saying, hey, if A contains a value, go ahead and unwrap it and stick that value into X. And then I can just use X like I normally would, right? This makes it a little bit easier in some cases, okay? But that's something that people sometimes don't spend enough time sort of really thinking about, which is in Swift. We'd like everything to be constants and nothing to ever be able to be nil. That's very safe. It's very predictable. There's no side effects. If we need things to be optional, we can do that, but that's unsafe. We need to explicitly do things to handle those things in a safe way, right? If we need data that's mutable, okay, we don't use a constant, we use a variable, but now we understand it's mutable if I'm using it for multiple threads, you know, other issues. So it just, another way to put it is Swift requires more work on your part to write code that's going to get you in trouble, okay? Now, I put some slides in here on Swift initialization because this just sort of shows taking this to the next level, because if we're dealing with integers and strings, it's pretty straightforward, but we're probably going to be building classes and defining objects from those classes. So another related error is what happens if you create an object from a class, but that thing's not fully initialized, right? It's got some constructors, some initializers that initialize the object. And so imagine for a second you're the developer of Swift, and you want to design the language in such a way that you make sure that it's safe, so nobody can ever create sort of a uninitialized object or a partially initialized object. And so how would you do that? And so the people who developed Swift, they said, all right, you're going to have these initializers, and we're going to have different kinds of initializers. We're going to have designated initializers and convenience initializers. The designated ones will fully initialize the object. The convenience ones are just there for your convenience. Okay, so let me just kind of just show you a quick little thing here. So I have a playground, and so this is a class person, and this is an initializer or a constructor from other languages you may be used to, and it fully initializes the object. It sets all of its properties, first name and last name, for example. Now, it could be more interesting than that. I could have one of these could be a constant. Now, a constant can be given a value in my initializer, but then it could never ever change later. That could be a good thing, right? Another thing we could have is, let's take a look at this, inheritance. So I have person, employee inherits from person. The initializer and employee here will call the initializer in the base class, because the base class needs to initialize certain things that belong to it. If I take out that call, I get an error here from the compiler. It says super init isn't called on all paths before returning from initializer. In other words, it says, wait a minute, if you're doing an initializer here, you've got to make sure to call the other one to make sure this thing is fully initialized. Again, safety, right? We could take another one here. Let's look at this one. All right. So I've got my person, and I've got this convenience initializer. And if I take out this call, again, I'll get an error that says self-init isn't called on all paths before returning. Because this is here just for your convenience, it's still going to have to call some other initializer to make sure this thing's fully initialized, right? So the reason I wanted to show this, though, is we're trying to kind of get an idea of sort of, yeah, Swift is a different language. It's got different syntax. When you declare a variable, it looks different than when you do it in Java or C#. That's nice, but what I'm really interested in is what makes it different when it comes to errors and crashes and things. So Swift does a good job of trying to identify issues at compile time instead of runtime, try to make things more safe, more high performant. And a good way to do that is the better control over mutable state and better control over making sure things are always initialized, okay? And so these rules, I just kind of showed them in code a little bit, but these rules are in the documentation. We talk about them in the 5-day course, but and so normally you don't have to remember all these rules, but they're there so that when you're creating your classes and your code, you don't sort of, you'll bump into these and the compiler will tell you, all right, hey, what you're doing here is going to result in an object that potentially is not fully initialized, right? You've got a convenience initializer. It's got to call an initializer from the same class. Or a convenience initializer must ultimately call some sort of designated initializer that fully initializes the thing, right? So you can have lots of initializers, lots of constructors, but Swift makes sure and enforces these rules to make sure your objects are always fully initialized, okay? Even if you've got some big, tree of objects, you have all these initializers set up in all these different ways, but the compiler will make sure that there's never sort of a way out here to make sure that your object is always going to be fully initialized. Okay, it's a little different than what a lot of people are used to. But once you sort of get some practice with it, you start to realize, hey, this is actually a really, really good thing. And in Swift, when you create subclasses, it'll even inherit your initializers if it can. If there's a reason why it can't, then it won't, and then you've got to implement it yourself. But again, it's just enforcing that safety, right? This is in the documentation too, okay? But it always makes sure that checks are performed and done properly, completely, and safely, okay? All right, so I mentioned Swift 4. We're kind of hit our end of our time here, but I just want to say when it comes to Swift 4 and Xcode 9, I recommend you do is one of the great things that Apple does is they make all of their stuff from WWDC available free to you as videos that you can watch. And so if I head over here to developer.apple.com, one of the videos here is what's new in Swift. And so it gives you a really good overview of sort of what's changing and what's new in Swift. And so maybe you want to go to swift.org or some other places to sort of get up to speed on the language. And then once you do, you can sort of read about what's new, or maybe go to our 5-day course and really dig in deep and get a lot of hands-on experience with using this stuff in depth. Okay, like I said earlier, not a lot of changes when it comes to sort of upsetting your life, but some good improvements with the string data type, some access modifier improvements, improvements in the area of application size, just sort of polishing things up now with Swift 4 and Xcode 9. So it's really, really good. Okay, and this is the Swift version of that application that I showed you before, where it'll talk to a web service, get some data down from the web service, and load it into a list view. And so we have a nice master detail relationship going on here. And so, again, I just wanted to just take 1 minute here just to show you, if I look at the code for this app while it's running here. Oh, that was the other app. That was our little button clicking app that we created. But let me go over here to the Swift one. We'll launch that one. But we start to see things like, here's my product class. And so my product class, hey, ID is a constant because IDs don't change. Name, unit price, units in stock, those are variables. They could change. Here's my initializer, right? Same with like category, okay? I've got some different initializers in here for being able to serialize this object into JSON, for example, or to turn it from JSON back into an object, okay? And then here's our app over here, okay? Yeah. All right. So we do have some time here. If anybody wants to throw out some sort of questions, you can feel free to do that. We've got the questions section in the interface there in the webinar. But again, the takeaway here wasn't so much, hey, let's all create a Hello World app in Swift. There's really a lot of places out there on the web where you can, there's great tutorials and walkthroughs for doing that. But it was trying to give you a feel for some of the things that we do in our 5-day course, but also show you maybe a little behind the scenes, a little bit of the thinking behind Swift and sort of how we try to make our code better, right, to make it more safe and less prone to errors. And, it takes a little getting used to if you're used to a different language. But then, once you understand a little bit about where they were coming from, what they were trying to accomplish, and then you start writing your Swift in that way, the end result is you end up with less errors and better code. Okay, cool. All right. I don't see any questions. Feel free to jump one in there if you want, but webpagesolutions.com. Right? We have, this is one place where you'll be able to access this webinar in the future if you'd like, and also get the list of the upcoming courses like I mentioned, as well as the 5-day one that's coming up next month. Okay. Cool. And I'm looking. Okay. All right. We'll wrap it up there. I hope everybody goes off and builds wonderful, great things with Swift. But just try to remember, right, some things that are legal in Swift are also legal in other languages, but just try to kind of think, what's the right Swift way to do this? Don't put all your semicolons on there and make your JavaScript, look like Swift. Make your Swift look like Swift, okay? All right. All right, we'll see you guys later. Have a good day. Bye-bye.